Welcome back to Quantum X. By this quiet lakeside, a project begins to take shape. A man starting with an aging shipping container. No new materials, only weathered steel and reclaimed wood. He isn't building from nothing. He's reshaping what already exists. A cost-efficient path demanding precision. Every detail must be solid, durable, well-balanced. Over time, this cold steel box will transform completely. If you've ever considered building a cabin like this journey is worth watching through. Let's begin. Old stickers tightly bonded to the steel surface. Not just cosmetic, but affecting paint adhesion. He removes each section with careful attention, clearing adhesive residue before moving forward. Next, the container is pressure washed. High-pressure water strips away dirt and grease, revealing the steel ready for treatment. Once dry, he moves to the roof. An elastomeric coating is applied evenly, a simple solution with lasting performance. It seals against water and reflects heat. He doesn't buy new, he finds them at a salvage yard. Doors and windows for around $300. A cost-saving choice traded for extra labor. Worn surfaces scratched and uneven. He begins sanding, removing old layers. Step by step, bringing the material back to a stable condition. Then repainting from scratch, creating a cleaner, more durable finish. Next, he turns to the container. Openings are measured from the inside, a method that improves dimensional control. He cuts through the corrugated steel, a critical step shaping the future livable space. But cutting is only the beginning. He welds angle iron frames for each opening. Angle iron, simple and easier to work with. Compared to square tubing, it requires less absolute precision during installation, well suited for uneven steel surfaces. The welds don't need to be fully sealed, only strong enough to maintain structural stability. He aligns everything with the container ridges, preventing frame distortion during installation. At this stage, the first openings come to life, not just for light, but a shift from enclosure to livable space. Not every cut turns out perfect. After test fitting the doors and windows, small gaps begin to appear. Minor inaccuracies, but clearly visible, especially on corrugated container steel. This is common in hands-on conversion projects. Old containers are rarely perfectly square, and with only a few millimeters off, the frame loses its tight fit. Instead of recutting everything, he chooses a more practical solution. Wood trim is added to cover the gaps, improving the finish while softening transitions. The wood also balances the industrial steel, creating contrast between warm and cold materials. In real construction, things rarely follow the plan exactly. What matters more is how the builder adapts to imperfections. With the openings completed, he begins framing the interior. But in this type of build, the framing is not structural. The container already carries its own steel strength. Here, the wood framing mainly supports insulation and provides mounting surfaces for the interior finish. At first, he rotates the framing horizontally, trying to gain more usable space. On paper, it adds nearly 10 centimeters of width, but in return, several technical limitations appear. The insulation cavity becomes much thinner, reducing thermal performance from the start. Routing plumbing and electrical lines also becomes harder, especially inside an already narrow container. This is a common trade-off when maximizing interior space. Next, he moves into insulation work. Spray foam is used around narrow gaps, sealing voids and reducing moisture intrusion. Across the larger wall sections, 1-inch foam board is installed, a lightweight solution and fast to apply. But the thickness remains limited. Steel containers absorb heat rapidly, and thin insulation struggles to maintain stability. The earlier framing decision further reduces insulation efficiency. At this stage, one reality becomes clear. Inside a container cabin, every centimeter affects long-term comfort. With the core structure complete, the interior finally begins to change. He uses reclaimed wood from an old warehouse, boards marked by years of exposure and use, faded gray, aged yellow, natural patina, uneven but full of character. This is not a perfectly polished finish, its beauty shaped by previous life. Every board carries different curves and tones, making installation far slower and more demanding. He constantly sorts, sands, and adjusts each piece, time-consuming work with a unique visual result. Inside the cabin, built-in shelves and recessed niches begin to appear, a smart approach for compact living spaces, reducing the cramped feeling common in containers. Less attractive boards are hidden in low-visibility areas, behind the bed or beneath fixed furniture, a practical and efficient use of material. But then another issue emerges. The container is broken into by thieves, forcing an earlier move to the lakeside. The entire container is loaded onto a truck, then transferred onto a barge across the water. A slow operation requiring careful balance. The steel structure weighs several tons. Once on site, the container is placed on support blocks. He levels each corner carefully, ensuring even weight distribution, a critical step to reduce long-term settling problems. For now, the cabin remains unfinished. A bed and sofa are placed inside first, mainly to test the feel of the living space. Electrical work is incomplete, water is not connected, the floor still awaits finishing. But the overall form is finally visible. And for him, this is only the beginning. The next plan is to build upward, adding a front deck and a rooftop living space above. Step by step, the old steel container becomes somewhere worth staying. With the container finally leveled, he begins expanding upward. But first, the roof structure must be reinforced. He welds heavy angle steel around the container perimeter, creating a stronger support frame for the added load. In projects like this, standard container roofs are rarely strong enough alone. They carry weight well at the corners, but the center roof panels can flex under pressure. But at this stage, the risks become more serious. Welding over a finished container roof is extremely dangerous. Heat can ignite insulation hidden beneath the steel, or silently damage finished interior materials long before it becomes visible. Finally, another elastomeric coating is applied across the steel and roof, a protective layer against water, rust, and thermal stress. The wood framing is then secured to steel using galvanized carriage bolts, better suited for wet lakeside conditions and more durable over long-term use. By the end of the day, most of the deck platform is complete, not only a future living space, but also the working surface for building the upper cabin. At this point, the project is no longer just a shipping container. It's becoming a layered living structure with real depth. With the upper cabin frame stabilized, he begins installing the subfloor, The material chosen is 1 1/8 inch Advantech panels, known for strong moisture resistance, and more importantly for reducing floor squeaks over time. Each panel weighs around 125 pounds, far heavier than standard plywood sheets. That makes positioning and alignment more difficult, especially on a narrow, elevated platform like this. But the added weight also improves stability, reducing flex and vibration under movement. He doesn't simply nail down the panels. Everything follows the manufacturer's specifications carefully. Construction adhesive is spread first, creating a stronger bond between contact surfaces. Then fasteners are installed at precise spacing intervals, helping distribute loads evenly across the floor system. The panels connect using tongue and groove edges, an interlocking system that locks each sheet together. This minimizes movement between panels and creates a more solid walking surface overall. Instead of building walls upright immediately, he assembles the wall frames flat on the floor first. He follows guidance from the Complete Book of Framing, a well-known reference in small residential construction. Stud spacing, load paths, and window framing are all laid out using standard framing principles, helping the upper cabin stay balanced and easier to finish later on. But at this stage, he avoids traditional nails. Instead, he uses structural screws, slightly slower to install, but far easier to adjust when mistakes appear. Screws allow partial disassembly, making adjustments without damaging the entire frame. The upper cabin is designed at roughly 8 by 10 feet, set slightly inward from the outer edges. This keeps the cabin walls aligned with the container below, giving the structure a cleaner overall profile. With the cabin frame stabilized, he turns to the roof structure. At first, the roof pitch is minimal, only 1/2 inch per foot, but after considering drainage performance, he increases it to nearly 1 inch per foot. A small dimensional change with major long-term impact. On each roof rafter, he cuts a bird's mouth joint for proper wall seating, a standard framing detail that transfers roof loads more evenly. Many of these rafters come from a dismantled old barn. The marks of age remain visible, but the core wood is still solid. Once again, reclaimed material finds a second life here. The cabin walls follow 16-inch on-center framing, while roof rafters are spaced at 24 inches, a common balance between structural strength and material efficiency. He also installs hurricane ties at roof connection points, small steel connectors with critical importance. They help anchor the roof firmly to the walls, especially under strong wind pressure. A 12-inch roof overhang is added afterward, not excessive, but enough to shield the walls from rain. A balance between aesthetics and function, minimalist in appearance, but practical over time. Finally, extra 2x6 blocking is added between rafters, reducing twisting and structural movement over the years, especially in exposed windy conditions. With the cabin frame complete, he begins enclosing the exterior. Instead of using a zip system, he chooses 7/16" OSB with house wrap, partly due to material availability and partly because cedar siding is highly vulnerable to moisture. Cedar carries a distinct natural beauty, but trapped moisture behind it can quickly shorten its lifespan. So the house wrap becomes a critical barrier, blocking water while still allowing vapor to escape, a key principle in modern wood construction. But the cabin location creates another challenge. The rear wall sits extremely close to the container edge, leaving almost no working space. He builds temporary scaffolding just to reach the back side safely. In tight builds like this, even holding tools becomes more difficult.
Once the sheathing is installed, the window openings are cut back out. He uses a handheld saw instead of specialized equipment. A practical approach requiring careful control. A slight mistake here could affect the entire exterior finish later. Inside the cabin, the ceiling begins transforming the atmosphere completely. He chooses to expose the roof rafters. Combined with cedar tongue and groove ceiling panels, the space immediately feels warmer, more rustic, and visually deeper. But this finish comes with challenges. The tongue and groove joints resist fitting tightly together, especially with natural wood shifting over time. He uses wood blocks to drive each seam into place, repeating the process again and again. Slow work demanding real patience, but also creating the handmade character of the cabin.
As the upper cabin takes shape, the temporary ladder no longer feels appropriate. He needs a staircase that is stronger. After researching several steel options, he chooses 8-inch C purlin in 14-gauge steel. Strong enough for residential loads, yet lighter than traditional heavy structural steel. The staircase is positioned along the side of the container, keeping the front deck area open and usable. He briefly considers adding a landing midway, but eventually removes the idea. A landing would force the stairs steeper and make movement less comfortable overall. Next, he calculates the stair stringers. The stringer length is measured using the Pythagorean theorem, a basic principle still essential in real construction work. The steel sections are cut using an angle grinder fitted with metal cutting discs. At first, only tack welds are applied, allowing adjustments before final welding. Another smart decision is rotating the open side of the C purlin outward. This creates a flatter interior face for mounting stair treads and gives the structure a cleaner appearance. The staircase is built roughly 30 inches wide enough for moving tools and wheelbarrows comfortably. During assembly, steel tubing and temporary wood braces hold everything in position.
Each stair tread is installed individually, measured, leveled, then tack welded first. An 8-inch rise between steps creates a more natural walking rhythm. But then another issue appears. The C purlins show slight warping along their length, a common trait in lighter, cold-formed steel. He uses angle steel and clamps, forcing each section tight before welding permanently. Throughout the process, alignment is checked constantly. Heat from welding can distort steel unexpectedly, and even small movement affects the entire staircase geometry. Finally, the stair top is capped with steel plate. The exposed ends of the C purlin are sealed shut, preventing moisture from collecting inside. The staircase is then anchored directly to the container, welded into the corner castings and structural corner posts. Additional bolts pass through the deck framing above, and at ground level, a concrete footing is poured beneath the outer stair supports, giving the entire structure greater long-term stability. At this stage, the cabin feels far more complete, not only visually, but structurally, like a permanent place beside the lake.
With the stair structure stabilized, he begins finishing the handrails. The material chosen is 2 by 2 inch square steel tubing, strong enough while keeping a clean industrial look. The stair angle is calculated at roughly 49 degrees, steep but necessary within the limited side space. Before cutting the actual steel, he first tests the angles using 2 by 4 lumber, a simple method but extremely practical, especially when steel is expensive to correct afterward. Even a small angle error can throw off the entire handrail alignment. During fabrication, he also shares lessons learned with welding over time. Tack welds are not only temporary supports, they also allow fast adjustments when mistakes appear. In metalwork, the ability to correct errors quickly matters greatly. He also points out a tool used constantly throughout the build, the clamp. Simple but indispensable, holding parts in position, pulling warped steel tightly back into alignment, and sometimes acting like a third hand during welding. Finally, the staircase receives its enamel finish coat, the same paint used on the container below, creating a more unified exterior appearance. Across each tread, he applies Homax TreadTech's anti-slip coating, a small detail but an important one, especially near a damp lakeside environment. At this stage, the staircase feels fully complete, not only visually, but safe and dependable with every step upward. With the framing and roof stabilized, he turns to the cabin's most important protective layer. HydroGap house wrap is installed around the structure, not only for water resistance, but also for moisture drainage behind the siding. To keep the roll controlled, he uses a long pole as a temporary support arm. A small trick, but extremely helpful without extra hands on site. He also avoids using a regular stapler, instead switching to a low-pressure nail gun, reducing the chance of tearing or overstretching the wrap. Then, everything is reinforced with cap nails, large plastic heads that hold the wrap securely in windy conditions. Once the wrap is complete, he installs drip edge around roof and window transitions, a small component directing water safely away from the walls. Every seam is then sealed carefully, leaving no exposed path for moisture intrusion. Even the window installation follows the manufacturer's flashing instructions precisely. In real construction, window openings are often the first place water enters. At this stage, the cabin no longer only looks complete, it begins performing like a real weather-protected home beside the lake. Old windows, used doors, and weathered lumber from previous structures. The cost drops significantly, but the labor time increases just as much. Each reused door requires adjustments to the surrounding frame. Some sections sit slightly twisted, others no longer hold their original angles. He removes, reinstalls, and realigns them repeatedly just to achieve smooth operation. It's the kind of work rarely shown on camera, yet it consumes a huge amount of time in DIY builds. Next, he focuses on waterproofing the front door assembly. The flashing work is done carefully. The flashing directs water outward, preventing rain from entering around the doorframe, because in most wood structures, water damage always begins at small connection points. Each layer is installed in sequence, so water sheds outward instead of trapping inside. A simple principle of modern waterproofing, but an extremely important one. At this stage, the project reveals an important reality. Saving money on materials does not mean saving time. Sometimes the real cost is patience and persistence from the builder himself. At the next stage, he returns to the challenge of insulation. He collects old flotation foam from dismantled dock systems around the lake. Most of it has already outlived its original purpose, but for him it still holds value. Marine foam resists moisture well and remains lightweight, ideal for container construction. But before installation, every piece must be cut to fit the framing precisely. He builds a homemade foam cutting machine, hoping to speed up the process. The concept works in theory, but the machine lacks enough power. Cutting the foam becomes far more difficult than expected, especially with thicker and larger panels. Some cuts come out rough. As the cabin nears completion, he begins bringing pieces of the old container back into the design. The steel panels cut from the container earlier are not discarded. Instead, they become feature elements on the exterior cabin and even within parts of the interior. Old scratches, faded industrial paint are intentionally preserved, a way of keeping the structure connected to its original identity. But for reclaimed steel to survive outdoors, it needs proper reinforcement. He adds angle steel behind the panels, keeping the surfaces rigid and properly supported. Then, the panels are welded securely into place. But with exterior metalwork, strength alone is never enough. Water always finds weak points along seams and edges, especially near a humid lakeside environment. So he installs drip edge above the steel sections, directing water safely away from the wall system. A small detail with major long-term importance. Next, the main exterior siding is finished with cedar. Cedar brings far more warmth than exposed steel, creating strong contrast against the industrial container below. At the cabin corners, he cuts the siding at 45-degree miters, a more demanding technique, but one that creates cleaner and more seamless transitions. Those sharp corner lines make the structure feel far more architectural. The soffits beneath the roof are first built using plywood, then finished consistently with cedar cladding, giving the entire exterior shell a unified material language. At this stage, the balance between reclaimed steel and cedar becomes clear. With most of the structure finally complete, he turns back to the surface touched every single day, the cabin floor. Once again, reclaimed materials return to the project. He salvages old pine boards from a dismantled barn structure. The wood carries years of wear, old nail holes, faded grain, and slight warping, but the core remains solid, strong enough for a second life inside the cabin. Each board is installed by hand, carefully aligned to minimize uneven gaps. Once laid down, the entire floor is sanded thoroughly, removing splinters and leveling subtle height differences between boards. The remaining gaps are then filled carefully, helping stabilize the floor through seasonal movement. Finally, a protective finish coat is applied across the surface, not only for durability, but to preserve the texture and color of the reclaimed wood. Originally, he planned to use reclaimed shiplap throughout the interior, a beautiful material choice, perfect for a rustic cabin atmosphere, but reality eventually intervened. High-quality salvage material was simply too expensive, especially in the quantities needed for the full interior. So instead, he switches to plywood, a far more practical solution, yet still consistent with the raw character of the build. The plywood exposes its veneer layers and cut edges openly. Not perfect, but honest to the DIY nature of the project. And throughout all of this, transportation remains one of the biggest challenges. The cabin can only be reached by boat. Every board, every tool must cross the lake first. That changes the entire construction process. There is little room for forgotten materials or repeated mistakes. At this stage, the builder's philosophy becomes fully visible, not chasing expensive perfection, but creating a space that is practical, durable, and deeply personal. First comes tar paper, a basic moisture barrier, still widely used in traditional roofing systems. Then, he adds insulation made from reclaimed foam panels, continuing the project's original philosophy, reusing available materials whenever possible. Above the insulation, a secondary wood framework is installed, creating ventilation space beneath the metal roofing, reducing heat buildup and trapped moisture. A critical detail, especially beneath exposed metal roofing systems. Without proper airflow, interior temperatures would rise rapidly during warmer months. Finally, he orders a custom-cut metal roofing package, supplied by a company specializing in steel buildings, allowing cleaner installation with far less cutting on site. A decision slightly more expensive up front, but one that saves major time during installation later. At this stage, the roof is no longer just a protective shell. It becomes a layered system, balancing weather protection, insulation, and architectural character all at once. With most of the structural work complete, he turns to the final details inside the cabin. The doors and window frames are repainted entirely, matching the color of the container below. A subtle visual change, but one that ties the whole structure together. Next, he begins wiring the electrical system himself, installing outlets, switches, and interior lighting by hand. In self-built projects like this, electrical work always carries extra pressure because even a small mistake can force major rework later. The wiring is routed carefully through the framing cavities, keeping everything organized and clear of insulation layers. Then comes the critical moment, the first power test. And surprisingly, everything works on the very first attempt. The first light inside the cabin changes the atmosphere completely, no longer feeling like a construction site, but a place finally becoming livable. From the beginning, the cabin was also designed around heat control. The front side uses fewer windows, reducing heat gain from harsh afternoon sun reflecting off the lake, a decision based more on comfort and efficiency than purely on maximizing views. Next, he begins building much of the furniture himself. Most materials are still reclaimed or free: old dock foam, leftover cedar, and salvaged scraps from earlier work. Every piece feels improvised, yet still connected to the cabin's overall character. One of the most interesting details inside the cabin is this custom-built bed. The core structure is made from reclaimed foam, lightweight, easy to shape, and built from available materials. Around the outside, he finishes it with leftover wood from the project itself. Foam and wood may sound like an unusual combination, but visually, it fits the cabin surprisingly well. The wood surface adds warmth to the interior, while the lightweight structure helps maximize the compact space. A bedside table is built from a tree slab section, finished with epoxy to preserve the natural wood texture. Artwork, reclaimed shelving, and handmade decor slowly fill the interior. The cabin begins carrying real personality now, no longer just a construction project. At this stage, it finally feels like a place to live, a space created not from expensive materials, but from countless hours of work and things others once considered worthless. As the rooftop deck nears completion, he turns to a detail that is both structural and visual: the perimeter railing system. And like much of this project, the railing is built almost entirely from reclaimed materials. Gradually, the railing system wraps around the rooftop deck, a simple layer of protection, but also a major part of the cabin's identity. At this stage, the project no longer feels like a temporary shelter beside the lake. It feels like a living space shaped directly from the materials and history surrounding the land itself. After 6 months of continuous work, the lakeside cabin finally takes shape. What began as an aging shipping container slowly became a real living space beside the water. Not through expensive materials, but through countless hours of hands-on labor. Some days were spent adjusting a single door frame or refining one small waterproofing detail for hours. At times, progress moved quickly, and at others, entire sections had to be rebuilt. But layer by layer, the reclaimed materials slowly came together. Old steel panels, weathered lumber from abandoned barns, even discarded dock foam now forms part of this cabin. And perhaps the most remarkable thing is how honest the structure still feels, not overly polished and never hiding the marks of handmade construction. Maybe that is exactly what makes this place memorable. Beside the quiet lake, it no longer feels like a shipping container, but a place to slow down, built patiently over time and persistence. Thank you for following this entire journey, and we'll see you again on the next videos.